Hello, this is going to be lesson 9.5. We're going to be talking about congruence today. Okay, our standards are going to be I can combine transformations. I can identify congruent shapes through a sequence of translations. This is standard G2. Understand that a two-dimensional figure is congruent to another if the second can be obtained from the first by a sequence of rotations, reflections, and translations. Given two congruent figures, describe a sequence that exhibits the congruence between them. So let's talk about combining transformations. We talked about that a little in our last lesson. So when you combine transformations, each new transformation is applied to the image of the previous transformation, not the original figure. So for example, what that means is, if I have triangle ABC here and I turn it upside down and do a little rotation, and then I want to do another sequence of transformations, let's say I want to do a slide, a translation, I'm going to apply that slide to this figure, not to that figure. So every step, I apply it to the one previous to it before it. Always label each image with the letter and coordinates that correspond to the letter and coordinates before the transformation. It'll save your mind a lot of trouble if you label all of your coordinates and all of your points with letters, okay? In other words, label the pre-image and the image. I can't stress this enough because it's super important to keep your mind straight on what's what. Algebraic representations of transformations. So you've learned some of the rules for how the X and Y coordinates change when doing rotations. And today we're going to look at the rules for how the X and Y coordinates change for all types of transformations you've learned about. So I'm going to do a demonstration under the document camera, and then we will continue. Okay, this is from the Explore on page 303. So I drew the first figure here, and we're going to do a series of transformations to this figure. When you're doing this, you're going to want to write your coordinates and your letters by each corner, each vertice. Make sure you do that. It's going to help a lot. So then you're going to start, before you even do these transformations, you're going to want to write the new coordinates. Super important before you even try to figure out where on the graphic goes. So the first sequence of events is I'm going to reflect across the x-axis. So what is the rule when you reflect across the x-axis? Do you know the rule? If you remember right, here's x, right? And here's y. When you reflect across the x-axis, the y value becomes the opposite sign. Okay, y becomes the opposite sign. So A was 5, 2, and now A prime is going to change the y value to the opposite. So it's going to become the 5 stays the same, but now it's -2. So it's going to be 5, -2. 3, 4, we're going to change just the y sign. It's going to become 3, -4. Hopefully you can see that okay. And if I zoom in a little bit, then this is 5, 4. It's going to stay the 5, but then the 4 is changing signs to -4. Whenever you reflect across the x-axis, y changes signs. And that would make sense because it's going from here to there, from the top to the bottom. If you reflect across the y-axis, x is going to change signs. It's going to be from this quadrant over to this quadrant. These are the negative values for x. Okay, hopefully that makes some sense to you. So there we are reflecting across the x-axis. So let's see what this is telling us. Apply the indicated series of transformations to the triangle. Each transformation is applied to the image of the previous transformation, not the original. Okay, so that's our first transformation. The next sequence, and I could show all of these, I guess we will. I don't want it to get too combobbled here. So 5, -2, 5, -2. This is the first transformation. 3, -4. And I'm going to write the coordinates here, important, 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. This is B, and these are prime. 3, negative 4. And C was 5, 4. It's now 5, negative 4. So 5, 1, 2, 3, 4, right where I was writing my coordinates there. So that's C prime, and that is 5, negative 4. So this is a reflection across the x-axis. It took a flip, went from here to there, and that should look like that to you. Step 2, we are now going to do, this means it's a translation. X is going to slide 3 units. Which direction is it going to slide? To the left or to the right? Well, think about your x-axis here. If you subtract 3 from any number here, are you going to be going this way or are you going to be going this way? Right, you're going to be going this way. 3 less is that way, right? 3 more is that way. So now we take the previous A primes, which was 5, negative 2, and where am I getting that? I'm getting that from here, or I could be getting it from my graph that I just wrote those on. And then I had 3 for B prime was 3, negative 4, and C prime was 5, negative 4. And I have gotten those from up here. Now I'm going to subtract, right here, subtract 3 from just the x value. The y is going to stay what it was. So this is a slide. So 5 subtracting 3 from that would give me 5 minus 3 is 2. So this is a double prime now. 2, comma, the y is staying the same, so it's negative 2. Now B double prime, it was 3. We're going to subtract 3. It's going to become 0, and the negative 4 stays the same. And C double prime, we're going to subtract 3. 5 minus 3 is 2. The negative 4 is going to stay the same. There's our second sequence of transformations. So now let's graph those. Now we're at 2, negative 2. 1, 2, 1, 2. 2, negative 2. That's our A double prime. 2, negative 2. Our B double prime is 0, negative 4. 0, 1, 2, 3, 4, negative 4. That's B double prime, 0, negative 4. And then C is 2, negative 4. 1, 2, 1, 2, 3, 4. This is C double prime, it's 2, negative 4. So this is our second sequence of transformations. We are now over here. The next thing we want to do is reflect across the y-axis. So we want to go from here to there. We want to flip. When we reflect across the y-axis, the rule is to change the sign of the x value. So let's move up here now. So reflecting across the y-axis, A double prime was, we can look it up here, we can look over here. I'm going to look here. 2, negative 2. B was 0, negative 4. You're going to have to do this. You can't just like try to do these in your head. There's just no way. 2, negative 4. And now we're going to go across the y-axis, so that means the x value is changing signs. 2 is going to become negative 2. We're going to leave y alone. It was negative 2, it stays negative 2. 0, well, what's the opposite of 0? It's still 0, so that's going to stay the way it was. Negative 4 stays the way it was. And the final one was 2. We're going to change it to negative 2, and the negative 4 is going to be left alone. So I'm going to try to zoom in a little bit so you can see that better. These numbers right here. Now I'm going to graph those. So I have negative 2, negative 2, 1, 2, 1, 2. We're going to call this A triple prime. A prime, prime, prime. Negative 2, negative 2. B is now 0, -4. 1, 2, 3. Same spot. So that's also B triple prime. 1, 2, 3. Okay, and then -2, -4. -2, 1, 2, 3, 4, -4. This is now the C triple prime. And it is right here. So notice how it went from here to there. It flipped. There to there, flipped. Next transformation is rotation. Oh, no, before that, a translation. A translation right here. X is staying the same, but Y is going to add 4. Is our translation going to slide up or slide down? If we add 4, it's going to go up. So let's write our A triple prime here. A triple prime was, let's get them from over here, -2, -2. B triple prime was 0, -4. C triple prime was -2, -4. Now we're doing a translation. We're adding 4 to every Y value. We're leaving the X value the same. So this is going to stay -2. If we add 4 to -2, we get a +2. Here the 0 stays the same. We're going to add 4 to -4. That'll give us 0. Here the -2 stays the same. And now we have -4, and we're going to add 4 to that. That's also going to be 0. So now we're going to graph these points. So we have -2 and +2. This is your A quadruple prime. 1, 2, 3, 4. -2, +2. Then we have 0, 0 for B, triple or quadruple prime. And then we have quadruple C, -2, 0. -2, 0, right here. So 1, 2, 3, 4. Connect the dots. That is a translation up 4 units from this one. Okay. And then we are going to rotate 90 degrees clockwise. Rotate 90 degrees. I'm going to try to keep this here. Let's put this up a little higher so we can see the whole thing. Rotate 90 degrees clockwise around the origin. So what happens? What's the rule when we rotate 90 degrees clockwise? That's going to put us at the bottom of the circle. What happens is the X coordinate changes signs to the opposite of what it was, and then you switch the Y and the X coordinates, or the X and the Y coordinates. So X is changing signs. Let's do that first. So we have, let's write what we had, -2, 2. B quadruple prime was 0, 0, and C quadruple prime was -2, 0. And I just said that the X value is going to change signs. So this is my X value, -2. It's now going to become +2. This 2 is going to stay what it was, right? But we have to switch. So this 2 is going to go first, and then that 2. But since they're both going to be positive, you won't really be able to tell. Same with 0, 0. You can't really switch the sign, and if you switch them, they're still going to be at 0, 0. This one, however, if we change the X, the -2 is going to become a +2, but then we have to switch them. So Y is going to go first, and then +2 is going to go last. So let's plot those on our graph. Let's see if I can zoom in. I have to look at this a little farther away. We have 2, 2. 1, 2, 1, 2, 2, 2. This is our fifth little tick marks. 1, 2, 3, 4, 5. 2, 2. That's our new one. And B is 0, 0. It stays there. And C is 0, 2. 1, 2. It's going to be C 5 times. 1, 2, 3, 4, 5. and that's 0, 2. And then we connect our dots, and this is where we end up. Right here, I'll color that one in. That is our ending transformation for our shape. Okay. I was just noticing something. I graphed 0, 2 wrong. Here's 0. I'm supposed to be having it right here. That's 0, 2. So this is where C 5th prime should be, which would then make the triangle go like this. Now it's really messy. Let's see if I can color it with a different color. So the answer finally is this. I just graphed that third point incorrectly. Okay, now when you do these sequence of transformations, that you already have done some of this on IXL most likely, you don't have to graph every single transformation to get to the end. You just have to do this stuff to get to the end and then get to that point. So you would just write the coordinates for each different transformation. And then when you get to the final coordinates, which are these right here, the final step, that is what you would graph here. So eventually it would start here and it would go all the way to here, but you don't need to do all these extra graphs getting there. You just have to do the coordinates. And you cannot do the coordinates without writing them down. So now if we look at it, did the size or shape of the original image change? No. Which transformations changed the orientation? Well, the rotations and the reflections, right? So if one figure is the image of the other figure, and a conjecture in geometry is, it's not provable, but yet it's pretty much known to be true. If one figure is the image of the other figure, there is a sequence of transformations, that's what we did over here, that will transform one figure into the other. So we did a sequence of transformations. These two are congruent because all we did was turn them, slide them, or rotate them. We did not dilate them, which is coming up. But dilation is changing the size of something. We're not doing that yet. Okay, so congruent figures. Two figures are congruent if one can be obtained from the other by a sequence of translations, reflections, and rotations, what we just demonstrated under the document camera. Congruent figures have the same size and shape. Again, we just went through that. When you are told that two figures are congruent, then there must be a sequence of translations, reflections, and or rotations that will transform one figure into the other. Here is an example of congruent figures. They have the same size and shape, and their corresponding angles and sides are equal. So angle A equals angle R. Angle B equals angle Q. Angle C equals angle P. The tick mark 1 here is also here. That means these two sides have the same length. 2 tick marks here, 2 tick marks here. These two sides have the same length. And then 3 tick marks here and 3 tick marks here. These two sides have the same length. And they use the congruent symbol, which is an equals with a little squiggly S above it. So that's how you would use geometry terms and symbols. Okay, let's continue. Okay, example of congruence. Identify a sequence of transformations that will transform A into B. So now instead of giving you the transformations, they want you to figure out what they were. So from this shape to this shape, can you tell what happened? Was there a translation? Was there a rotation? Or was there a reflection? Or was there a combo of both? I bet you can tell. There was a transformation. It was a reflection over the y-axis. So it flipped. It went from this side and it flipped to that side. But if it had just flipped, this point here, let me get my little spotlight out. This point here over the 1 would be this same point here, and it should be over -1, but it isn't. So there must have been something else that happened besides a reflection. It slid, so there was a translation. How many units was there a translation? 1 to the left. So there was translation was 1 unit to the left. So you would be subtracting 1 from the x value. If we were going to show this algebraically, xy would result in -x comma y because the reflection over the y-axis changes the sign of the x coordinate. And the second one would be x minus 1 comma y would stay the same, and you would subtract 1 from every vertice for the x coordinate. Identify a sequence of transformations that will transform figure B, the red one, into figure C, the blue one. Can you tell what happened now? Is there a reflection? Is there a translation? Is there a rotation? Step 1, there is a rotation of, then you got to figure out how many degrees, 90 degrees counterclockwise. So it rotated along the origin here to there. It went this way. It's a counterclockwise. Oh no, maybe it went this way, 90 degrees. It did, it went this way, 90 degrees. So it went counterclockwise 90 degrees, 1/4 of a turn. And then it was translated up 2 units and 1 unit to the right. And that would look algebraically like that. You would have xy as a rotation counterclockwise. They would switch places and y would become negative, and then you would have adding 1, adding 2 to the x and the y for your translation. Okay, let's look at these. Identify a sequence of transformations that will transform figure D into figure E. What do you think? So you're going to rotate 90 degrees clockwise around the origin. So that's going to go clockwise is, let me just draw it. Clockwise is this way. 1/4 of a turn. That's why it's up and down now instead of left and right. Okay, that's the first transformation. The second one is it's going to be translated 6 units down and 1 unit to the right. 6 units down and 1 to the right. Algebraically, it went a rotation of clockwise 90 degrees. X is going to become negative, and they switched places. And then the second one, x is going to, well, this one is wrong. That should say x plus 1. Hold on a sec here. See, we all make mistakes. 1 unit to the right. Oh, wait, it's going to the right. Yep, it's increasing. X plus 1, y minus 6, because it went down. So that's the second algebraic transformation. Okay, let's resume. So you're going to just have one your turn today, and that's all you're going to be answering is the questions from this video. There are no 2 your turns today. So for each algebraic, let's talk about this a little bit, higher order thinking. For each algebraic transformation shown below, describe a possible sequence of transformations. So you're going from -x minus 2 to y plus 1. So you're changing the sign of the x value. You're sliding it 2 to the left and adding 1 to go up. So when does the x value become negative? When you reflect over the y-axis. So it's a reflection over y-axis, and then it's a translation. So translate 2 units right and 1 unit up, and then reflect across the y-axis. How about this one? Y, comma, negative x minus 3. Well, we've switched places with x and y. That has to be a rotation. Rotations are the only ones where the x and y switch places. And then if the x becomes the negative, I believe that's the 90-degree clockwise. And then we're subtracting 3 from the new y value, which means it's a translation down. So you're going to rotate 90 degrees clockwise around the origin, and then you're going to translate 3 units down. So get familiar with how to read these. Okay, and I just wanted to show you that a transformation of a function, you're going to be talking more about this next year. All of these letters in an equation mean something about the transformation. So we have y is your y-coordinate. This negative sign is present when we reflect over the x-axis. A is if A is greater than 1, it's a horizontal stretch. If it's between 0 and 1, it's a vertical compression. F means it's a function and it must pass the vertical line test. And then you have the negative sign. If the negative sign is present here, it's reflecting across the y-axis. B stands for, if it's greater than 1, it's a horizontal compression. If it's between 0 and 1, it's a horizontal stretch. X is the x-coordinate. And then x plus h shifts the function right, or shifts the function left. And fx minus h shifts the function right, depending on whether h is less than or greater than 0. And finally, k, we've talked a little bit about that this year. That shifts the function up or it shifts the function down. So you're going to be learning about each one of these things and what they mean in an equation. So Mitchell says that point 0, does not change when reflected across the x or y-axis or when rotated about the origin. Do you agree with Mitchell, and why or why not? I agree with him. Why do I agree with him? Because you reflect across the x or y-axis, you change the sign of either the y or the x coordinate, but 0 cannot change signs because it has no sign. And then if you rotate about the origin, it doesn't change the origin. It's still going to be 0, 0. Triangle ABC has the following vertices, -2, -2, -3, -1, and 1, 1. It is translated by the equation x minus 1, so it's going 1 unit to the left. Y plus 3, it's going 3 units up. Then the image triangle A prime, B prime, C prime is translated again, this time to x plus 4. 4 units to the right, y minus 1, 1 unit down, resulting in A double prime, B double prime, C double prime. Find the coordinates for the vertices of A double prime, B double prime, C double prime. So you can try this one at home. This would be your ABC, right? You're going to be translating it. So you're subtracting 1 from every value. So -2 minus 1 is -3. -3 minus 1 is -4. And 1 minus 1 is 0. And then you're going to add 3 to the y coordinates. -2 plus 3 is 1. 1 plus 3 is 4. And 1 plus another 3 is 4. That's the first translation. Now we have to do the second one. So A double prime, we're going to look at these points and we're going to add 4 and subtract 1. So adding 4, -3 plus 4 becomes 1. -4 plus 4 becomes 0. And 0 plus 4 becomes 4. subtracting 1, 3, or 1 minus 1 is 0, 4 minus 1 is 3, and 4 minus 1 is 3. So those are your answers. Write a rule for one translation that maps triangle ABC, the original triangle, to the second transformed triangle, A double prime, B double prime, C double prime. Is there one translation that would do the trick? There is. If you combine the two translations, translation 1 is x minus 1, and translation 2 is x plus 4. So you combine them. -1 plus 4 is 3. So the two combined translations would end up being x plus 3. So if you just added 3 to the original x's, you would get these, okay? And then you combine the y translations. The first one was adding 3. The second one was subtracting 1. So 3 minus 1 is 2. So if you just did y plus 2 from the original vertices, you would get A double prime, B double prime, C double prime. Give it a try at home. So there is your new translation, x plus 3, y plus 2. Okay, I lied. I guess there is a your turn number 2. I will see you back shortly. Actually, I don't think there's a your turn number 2 or 4. I think I had too many extras in there. That's what I did. So I didn't lie after all. There's only one your turn. And your homework, it's supposed to be saying lesson 9.5 as well. Okay, now I fixed it. It says the homework is lesson 9.5. And just to be fun today, I thought I would say goodbye upside down. Bye. See you next time.